Hi everyone. In this video, let's talk about my current final year project along with my friends in autonomous weight carrying robot. According to the US Bureau of Labor Statistics, during 2019 to 2020, a lot of non-fatal accidents are occurring to workers who are involved in construction as well as mining. So we thought about a solution that could drastically change this problem in the current scenario. And that solution was autonomous weight carrying.
Our autonomous weight carrying robot is used in construction sites. The existing technologies like AGVs are used in industries. We know that these AGVs are used to track path and carry loads in flat surfaces. But our robot has also the capability to travel in rough terrains by the help of computer vision technologies to track paths. It has a payload of 50 kg.
Our robot has two modes of operation: Bluetooth control mode and autonomous lane tracking mode. We have a Bluetooth app to control the robot to move it in forward and backward, which can be also be done in autonomous mode. There is an unloading mechanism in our robot, which can be also be controlled manually. The mechanism is done by a lead screw.
Our robot has a truck-like structure to carry load with a capacity of 50 kg. The body of the robot is made with metal square pipes and covered with metal sheets, which is very strong enough to carry weight. The dimensions of our robot are: it has a length of 80 cm. The width of the robot is 40 cm. The height of the robot from ground is 50 cm. Then it has 4 wheels. The wheels are of diameter 24 cm. Then the storage capacity of our robot. The back portion of the robot has dimension of 50 cm length, 28 cm height, and 40 cm of width. The steering mechanism is the Ackermann steering to turn left and right. The weight of the robot is about 15 kg. At the unloading mechanism, it is lifted using a lead screw, and the back portion is attached with the body using hinges to lift up and down. Then there are physical buttons to turn on and off. Then for unloading mechanism, there is another DP/DT switch which is provided, and there are other switch for mode selection, autonomous mode and Bluetooth control mode. There is a LED display which shows battery information and the modes which is selected.
The software of our robot mainly depends on OpenCV packages. The method for finding the path is in such a way that, first of all, it gives a threshold for finding yellow screen inside the image, and from there it goes on for a Gaussian blur, which helps remove edges which are not required for our model. After removal of the edges, we move on to applying canny edge detector to find the path edges which are supposed to be found by the robot. After finding the edges, we move on to applying Hough transform. Now, Hough transform is basically used to find the slope of the lines inside the image, so that our robot will be able to estimate the current signals that are required for turning the steering wheel. Now, what happens after this algorithm generates an integer? Let's move on to those parts. First of all, the algorithm, after generating the integer, which might be varying from a negative value to a positive value, will send this signal to Arduino Uno through serial communication. The Arduino, after receiving this value, will determine at which direction our robot's steering is supposed to move, and according to that, our robot will move and try to get the robot inside the lane which is supposed to be moving. Now, at that point, we found out a very common, not just a common, a challenging situation, as our robot was mainly depending on Ackermann steering it was hard to implement the turning operation accurately. So, a method of feedback was supposed to be generated in our robot. From there, we introduced an idea using Hall effect sensors. We used 3 Hall effect sensors to get the readings of the position of our steering so that we are able to estimate the control signal for moving our steer. In that way, we were able to accurately generate the control signals for the front steering wheel. Applying these features, the result was marvelous. We developed a robot which was currently used as an autonomous weight carrying robot prototype, creating a marvelous solution for the problem which I mentioned in the start of the video. We are concluding our video here. Thank you.